X2AP radio part protocols. We do that at a later stage, but now we are starting with core network side protocols. So the first one among that is X2AP protocol. X2AP, X2 application protocol on X2 interface. So the concept of procedures do continue for all these application protocols in LTE. So we have the procedures even in X2AP. So even those procedures are also classified. Indeed, the procedures are classified into two categories. Whatever the information that gets exchanged between one node B to another node B is classified into class 1 and class 2 procedures. So what is the primary difference? On what basis they have differentiated these two classes? The procedures which are having a response, either it is going to be a successful response or a failure response. So such a thing is what we call as class 1 messages, elementary procedures with response. Elementary procedures without response are typically called as class 2 procedures without a response. That means we send a message, the other guy is not going to send any response back. We don't expect any response. So two categories: with response, without response. Simple. So every procedure may consist of n number of messages. Every message may consist of m number of IEs, information elements, and every IE contains a value. Every information element contains a value. We knew that already. So this logic is already known to us from studying RRC and NAS. Now, that is not only the classification for the procedures. In another way, we can define the same X2AP procedures into two other categories called as X2AP global procedures and X2AP basic procedures, basic mobility procedures. So what is the difference between these two again? Global procedures are the ones that are getting exchanged between the node Bs, not related to any particular mobile phone, not related to the mobile phones. But if the basic, if the procedure between two node Bs is related to the mobility of a mobile user, like a mobile phone, then those are called as basic mobility procedures. So this is another way of dividing it. And don't think that we have totally 4 types of procedures. No, the total available X2AP procedures, depending on the whether a message is containing a response or not, if you segregate it, they are divided into class 1 and class 2. But the same procedures, if you look into it and say whether these are UE specific procedures or non-UE specific procedures, based on that, if you do a division, they again will be categorized into global and mobility procedures. For example, if you have humans, if there are some number of students gathered at one particular place, you can basically like do what? You can segregate them on the basis of their maybe their percentage of marks they have secured in their degree. You can divide them like maybe above 50% and below 50% marks scored. So we can divide it that way. Our other way of dividing it is like the same students, we say, hey, whoever are here with a height more than 5.5 feet and the ones who are having less than 5.5 feet, we can divide them in another segregation. So same kind of concept here. Okay, so first we are going to start with is the global procedures that gets exchanged between two node Bs. The general communication mechanism between node Bs, not related to any particular mobile. So if two node Bs are talking to each other with global procedures, they are interested in their general activity. They are not talking to each other about any particular mobile phone in here. So the starting procedure that we have is called as the X2 setup procedure. Okay, so we are going to see what is this X2 setup procedure, and how it gets introduced. X2 setup procedure is to create a relationship between two adjacent InnodeBees. So the very first message that two InnodeBees will exchange each other is this X2 setup to become neighbors with one another, to become friends. And now, with how many InnodeBees a particular InnodeBee must establish this X2 setup procedure only to the neighboring InnodeBees. For example, if there is a InnodeBee in Hyderabad, if there is another InnodeBee in Bangalore, these two guys never need to exchange this X2 setup because there is no way mobile phones can actually jump from Hyderabad cell to Bangalore cell. So these two InnodeBees never need to talk to each other about handovers of the mobile phones. So they never need to create relationship. They never need to become neighbors with one another. So typically every InnodeBee will try to make relationship with only maximum like 6 to 10 InnodeBees in the surrounding. That too like neighboring InnodeBees. So in different geographical conditions, you will have different number of InnodeBees in the adjacency. With only those InnodeBees, you will try to patch up a relationship. You try to establish a relationship. So that is the idea of this X2 setup. Okay. So in this procedure, how many messages we have? So we have InnodeB1, we have InnodeB2. InnodeB1 is sending a message X2 setup request to InnodeB2, and that guy is responding back in a successful operation. There could be a failure operation as well. If one guy proposes that let us become friends with each other and our neighbors with each other, the other InnodeB might accept it or might reject it with a failure. It will quote a reason for why it is rejecting it, and it can keep quiet. Okay, so let us look into these details that are going to be present in this X2 setup request. Let's look into the details. Um, so the proposal, the X2 setup request proposal from one InnodeB to another InnodeB. What details it is quoting there? So here we have the X2 setup request contains lot of IEs, information elements. Um, we study these information elements one by one. You have global InnodeB ID, sorry, first message type. What is the type of message we are sending? Of course, the type of the message will have a code that represents that this is a X2 setup request message. It will have that code. Then we have the global InnodeB ID. Uh, the InnodeB which is proposing this connection is giving its InnodeB ID here. And then we have um, served cells, how many cells it is going to contain. For each cell, the information related to ECGI, Evolved Cell Global Identity, PCI, Physical Cell ID, and ERFC, and the frequency details, etc. So you are quoting how many cells the InnodeB is containing, and for those cells, how many neighbors are there, and which neighboring cells are having what IDs. So you're quoting all these information. And there is a concept called as InnodeBees working in pools. If operator is creating the InnodeBees working in pools, your InnodeBees will be containing a group ID on which they are part of. So to do the load balancing among the InnodeBees. So if operators are implementing such kind of a procedure to do the load balancing among InnodeBees, they will configure this group ID. Okay, so that information would be included. So So these are the kind of details that normally are going to be present in your X2 setup request. So basically, one node B which is proposing the relationship with the other node B is giving his own details. Hey man, I am so and so. My ID is so and so. I have these many adjacent cell with your cells, and I belong to so and so pool. In the pool in the load management point of view, from more load management point of view. So this is the kind of general information. It is just like two neighbors becoming, like friends by talking to each other for the first time. Like how many children you have, how many children I have. So kind of details. So you're just exchanging the generic information. And if the other node B is successfully responding back, it would respond back with the X2 setup response. Um, So in the successful response scenario, the other guy is going to provide its ID and what cells it is containing and the neighboring list it is containing. So all these neighboring related information will be configured by the operator. So when operator configures these details, nodebs know how many cells they have themselves, and these cells are adjacent to which other cells in the adjacency in the neighbor. Um, so those kind of details that you are advertising. And if the other node B also belongs to a group, it will be quoting the group ID as well. So just exactly almost the same information that is proposed by that is sent by one node B, the other node B is also sending the same information. Because when two node Bs are becoming friends, it is like an equal relationship. You will be exchanging similar kind of details. And then one additional parameter that might be there, but actually it is optional, called as critically diagnostics. Normally, these critically diagnostics can be included when the component who is responding back, if it has to respond back in any kind of a negative way, it need to explain to the sender of the message that there is something wrong in the thing that you have sent me or something like that. It will be including this critically diagnostics. If everything is good with the message that is proposed by one node B in the form of a request, the other node B has no business to include this critically diagnostics. I hope you understand the meaning of diagnostics. Normally, we use this in a medical term. We see this as a diagnostic centers, which will do a lot of like a kind of medical test and find out what sort of a problem your body is having. So that in the terminology we use this day-to-day word diagnostic. So critically diagnostics, that means which are critical that are observed by the receiver, reporting back to you that I see some issue with the message that you have sent, like or whatever the wrong thing that you need to report, you will be including it to it. So what details will be present in this critically diagnostics? It explains I'm reporting this critically diagnostics as part of which procedure, which message has caused me to generate this critically diagnostics IE, and what is the criticality, um, and what is the IE's criticality, and what is the IE which has caused that IE ID, what kind of error I have seen, whether that IE is not understood or the IE is missing, like a mandatory IE is missing, like that you quote the reason, like what kind of a error you have seen in this IE. So you try to go to top to bottom, which procedure has caused you to generate this critical diagnostics part, which message in that, which IE has caused it, and what is the IE ID, what kind of a error the receiver is trying to report you. So every detail will be included in the form of critically diagnostics. Okay. Typically, what is the meaning of this word criticality? What does this criticality refers to? For example, if you go back, sorry, if you go back to our original um, S1 setup request, every IE there is this presence which is set as MMMM, which stands for mandatory. But there is this thing called as assigned criticality, like reject, like that. There is some criticality here. Typically, this kind of a criticality word that we see in two protocols, X2AP and S1AP protocols, we see this criticality. What is the meaning of criticality? What are the different values that we can have? Mostly you see three values here: reject, ignore, okay, and there is one more thing called as um, forgot, uh, like report or something like that. I'm not getting the other word. Um, Reject, ignore, and notify, which is like so. These are the three values you typically see. What is the meaning of reject? The meaning of reject is you are indirectly telling to the receiving guy of this the message receiver that hey man, this IE information element is very important for you to understand. If you cannot understand this IE that I am sending it to you for any reason, you must reject the procedure itself. You must send a rejection to me. Okay, so you should not take it lightly. So it is a indirectly you are conveying to the receiving guy that this is a very, very important IE. I want you to understand it very well. If you cannot understand it for any reason, so you should be rejecting this message. So that is the meaning of reject. Ignore means if any IE is assigned criticality value would be set to ignore, you are informing to the receiving guy that if you understand it is well and good, but if you don't understand it, you can ignore it. You can just forget about it. So that's ignore. What's the meaning of notify? If you cannot understand or if there is any problem that you see with this information element, um, it is fine for me, no problem at all. But you notify that to me. So that means you are not going to reject the procedures that I have initiated because you don't understand that IE, but you are going to report it back to me that I did not understood this. So you have to notify it. So these are the three kinds of values that would be typically set to these IEs, information elements. Right now in the message that we have seen, mostly the IEs are containing a value reject or some of the um, actually every IE should be having this assigned criticality. Now you can argue and say, hey, there are a lot of IEs. Why we have the criticality applicable only for few IEs? No, actually, how many IEs are there in this message? When we count that, this is one message, this is one IE, this is one IE, this is one IE, and the next IE we have is this only. These all these things, single arrow means it is the first level information which is present inside this. Two levels, two arrows means it is the information present inside first level thing. So it is that way you have to understand. So basically, this is the top level element. These are the second level elements. Inside this second level element, we have next level elements which are present inside this neighboring information. So that is how we have to understand. They are not IEs. So they are the pieces of information present inside this IE called as served cells. Same way, this GU group ID also is not an information element. It is a inside element of your GU group ID list. It is an inside element there. Okay, so that's the primary point we have. Um, so so that is the assigned criticality part. So that is what is represented here um, in this critically diagnostic content. What is the IE criticality and what is the IE ID? What kind of a error that the receiver has observed with the received information element? Is the information element missing or not understood or whatever he would like to report? It can report back in the form of it. Just like how your IE has got criticality, your procedure also will have the criticality, or your triggered message also can have the criticality. If the criticality is set to reject, if the receiving component cannot understand the triggered message, it is supposed to send back and reject for that protocol message. It is supposed to send back that. So that is the meaning of um, That's the meaning of this word, procedure criticality. Here we see that at a later stage. But as I told you, so if the reply is coming back, if the reply has to carry any critically diagnostics information related to any of the IEs, so that information need to be included. Otherwise, this is optional. It may be there, it may not be there. Okay, great. Now, this is a positive scenario, but what is going to be the negative scenario? If the other node B is rejecting the X2 setup proposal sent from one node B, it can send this X2 setup failure when it wants to reject it. So in this, what details we have? A message type, which is set to X2 setup part. Then we have the cause, time to wait, and critically diagnostics. We have these details present over here. Um, so what is these parameters? Message type is as usual. Cause, why it is reporting the failure. So this cause is a big list of causes that are possible in X2AP interface. So whenever any X2 procedures need to be rejected, it can be rejected with various reasons. So those reasons are listed here basically. All those reasons are listed here in this table. That's all. Um, so what and all the different reasons that could be quoted? Um, Radio related reasons can be quoted, transport related, protocol related, miscellaneous related. So miscellaneous causes, protocol related causes, transport related causes, or radio network related causes. For example, one enode B proposes X2 handover to the other enode B. The other enode B might reject it with miscellaneous cause, value set to control processing overload. So other enode B is rejecting and telling you that, sorry man, right now I'm having too much overload on my signaling message processing. Can you come back to me a little later? It can it can tell you that. So that kind of a cause, or it can tell that warn them intervention. So what is the meaning of warn them intervention? WONDM stands for operation and maintenance. So some person who is working on the Inode B has rejected this proposal. So it has popped up to one human being. Human being might have rejected it, or your Inode B's configuration itself has not allowed making a connection to the other Inode B's proposal. So it's not allowed like that. So it could be quoting any of the reasons, or it can say that, hey, man, the message that you have sent me is not compatible with my receiver state. I'm not in a state to process your message and reply back. So come back to me a little later. So like that, it can quote any of the reasons depending on its own analysis. It can revert back to the component who is proposing the message, and it can reject that message. So these are all different rejection causes in different procedures. And don't think that all these causes are going to be applicable only for the thing that we are studying. No, it is not. It is applicable for all the procedures in X2AP mechanism. It could be for any procedure. Okay, great. What next we have? So it can quote the cause, why it is rejecting the setup, and it will also give a value called as a time to wait, how much time you have to wait before reattempting this X2 setup once again. And then if required, it might include this critically diagnostics explaining you know why this problem has been caused, due to which information element this problem has been caused. If at all any information element that is sent by the sender is causing the issue, then that kind of a report will be attached along with the cause. For example, in the cause, it can set to a value like a semantic error. Okay, it can set to this value semantic error, and then it can have this critically diagnostics, which is containing that one particular information element, saying that one important IE, like a mandatory IE, is not present, is is not present in the message that you have sent me. That is why I'm rejecting it. It is like that. It will be like a combination. It'll be sending the cause and the critically diagnostics both. So once this X2 setup request is exchanged between two eNodeBs, eNodeBs will become friends with each other. So from then onwards, they started to work on, like handovers between them from that moment onwards. So that is the actual purpose of establishing this X2 setup mechanism to, have a relationship, adjacent relationship with one another. So the next procedure is X2 configuration update procedure. And please remember the previous procedure that we have studied is class 1 procedure, because the message that we have the message that we have sent is actually having a response from the other side. It is indeed having a positive response and negative response also. So it is having that response. So definitely that is a class 1 procedure. And when you think about whether it is a UE specific procedure or a global procedure, we can clearly say that it is a global procedure, because two eNodeBs are making friendship with each other. It is not related to any particular mobile. It is a global communication that is happening. It is general information exchange between the eNodeBs, not specific to any particular mobile. So, so from the classification of the procedures that we have discussed at the starting, the previous procedure we have studied falls into that category. Now, the next procedure that we are now discussing is X2 configuration update procedure. Okay, so what is this? One eNodeB sends configuration update to the other eNodeB sends configuration update acknowledgement. Okay, so what details would be there inside this configuration update part? So before we see that, we also see that there is a possibility for a failure. First of all, what is the meaning of configuration update? After two eNodeBs becoming friends with each other with the X2 setup procedure, if at all any configuration gets changed on the eNodeB, that eNodeB need to report it to the other eNodeB. Hey man, some new cells have been added on my side, so I'm reporting it to you. Okay, so it's like that. You have to report every change that happened on your side. You have to explain it. For example, if two neighboring families will exchange every important information about their family. Okay, say, my kid's marriage is, we are planning maybe in the next 4 months we might have a marriage in place, or this summer we are planning the marriage, something like that. So if any updates happen, you will be exchanging with each other. So here, the guy who is proposing this configuration update telling that I am adding some cells, or I am modifying some cells, or I am deleting some cells. Something is happening on my side. I am doing one of these three activities: adding, or modifying, or deleting some cells, or I am now part of a new group, or I am now moving away from a particular load group. So you can even send that kind of information also. So it is all about keeping the other eNodeB updated with your changes. So if other eNodeB decided to accept your eNodeB configuration update, it successfully notes down the changes that you are proposing. It will reply back with eNodeB configuration update acknowledgement with not many information elements present inside. If one eNodeB proposed a handover, sorry, if one eNodeB sent a configuration update, doesn't mean that the other eNodeB said configuration also must be changed. It is not that. If one eNodeB is proposing a update, it is only from his side. There is a update happening. The other eNodeB just silently need to note down that information, come back to you and tell you whether it is accepting it or rejecting it. So not much details are present in the configuration update acknowledgement other than the message type and an optional critically diagnostics if at all the um, receiver, if he wants to report about any problems with the information elements, it need to include this critically diagnostics. Otherwise, that will be absent. Only one parameter will be present in the message, that is message type. The moment the sending the procedure triggered node B received this acknowledgement message. It understands that the other node B successfully noted down its changes. But if one node B, when it proposes, if the other node B is going to report a failure, it will definitely have to quote a cause from the list of causes which we have already studied, and then time to wait and critically diagnostics if at all the problem occurred due to an information element, you need to include the details in the form of critically diagnostics. All right. So that is that. Next procedure which we are going to study is X2 reset. So what is the meaning of X2 reset? If one node B suddenly goes down and comes up due to any failure or any problem that occurs on his side, it need to report to the other node B that uh, there is some severe thing happened on my side due to so and so problem, and I came back after going for a shutdown, and whatever the relationship that we are having earlier, I don't did not remember anything related to that relationship. I forgot everything, so we will give a fresh start. That is the meaning of this X2 reset. So the enode B, which is proposing the X2 reset, will explain the reason for reset happened on his side, and the other enode B will simply have to accept this reset response. So before the reset. Before the reset is sent by one enode B, these two enode Bs may be actually talking to each other related to some 50 different handovers of 50 different mobile phones. Now all that information is gone. So for enode B1 is reporting to enode B2 that I did not remember any relationship that it was happening between me and you. I forgot everything because of a reset occurred, because of a failure or because of a problem occurred on my side. So I'm proposing for a fresh start. So let us start with the fresh start. That is the meaning of this reset and reset response. So the node B which is proposing the reset have nothing much to say. It will simply include the message type and cause of the reset. It will code the reason why it is why the reset occurred. It'll quote the cause from the list of causes that we have already studied. Okay, so from this cause list, one of the cause will be, for example, it can report that hardware failure. So there is suddenly a processor has got restarted on my side. Hardware failed because due to the hardware failure, and that is why I had to go for a reset. So something like that. It can quote any relevant reason, and it can propose for a reset. So the other guy is sending the reset response. It say that it's okay, no problem at all. Let us do the way that you have proposed. So it will report back reset response. Message type only will be there. Of course, the critically diagnostics is optional. Anyway, there is nothing much the critically diagnostics can do here. Only there are two messages, two information elements here. One is the message cause, and the second one is the cause of the reset. Why the reset occurred on a node. Okay. Um, so the next procedure, okay, remember, so far all the procedures that we have studied are global procedures itself. They are not any UE specific procedures. They are global procedures. Now we have the resource status procedure. What is the resource status procedure? How it works out? One node B tells the other node B that, hey man, I would like to know the resource situation on your side every now and then every X amount of time. Please keep reporting your resource related details. The other node B need to either accept it or reject it. For example, if it accepts this successfully resource status response, uh, it from then onwards it will be sending the reports to this node B about his resource status. But if he decided to reject it, it can reject it. But if it is rejected, node B2 is telling that, sorry man, I cannot provide you my resource status information to you because of so and so problem that I am facing. It can report back this failure. Now, if it is accepted, if it is a positive scenario, once it is accepted, every X amount of time, we will be sending a message called as resource status update. Now, these two messages are class 1 messages because they are having a reply. So definitely they are class 1 procedures. When we send a request, either we are getting a positive response or we are getting a negative response. But this procedure is a unidirectional message and it is falling into class 2 because it is not having any kind of a reply. Every some X amount of time, enode B will be reporting his status details to enode B1. So what is the purpose of the asking for the other node B's resource status and why the other node B is reporting it by accepting it? This is the purpose of dealing with your handovers accurately. If node B1 knew how much amount, what is the kind of situation the node B2 is facing, then node B1 can plan his handovers in a better way. For example, if node B1 complains to node B, so node B2 explains to node B1 that, hey man, right now all my resources are getting allocated. I'm actually facing huge amount of pressure for resources from a lot of mobile phones who are in connected state. So this is a really, really pathetic situation to me. Enode B2 reported that to Enode B1. So what does Enode B1 do in such a scenario? What does Enode B1 do? Enode B Enode B1 says, okay, um, that's a bad situation Enode B2 in. If any mobiles wanted to go for a handover into any one of the Enode B2's cells, I will try to delay that handover as long as I can. I will try to hold those users in my cell itself as long as I can because I know that Enode B2 is really facing the problem. In that problem situation, I will not attempt too many handovers and move my mobiles into Enode B2's cells because he's already facing the issue. So to do these load-based handover decisions, this information would be useful to make these load-based handover decisions. So that's the purpose of exchanging this resource status. Like what kind of resources that you typically request for? You will be requesting for three types of resource status. One is the radio resource status, like how many resource blocks are getting continuously allocated to the mobile phones. Is the resource block allocation status is like 90% or 80% or whatever, how much our resources that B2 is continuously allocating to its users, it will be reporting that to B1 in the form of a resource update. Hardware load. How much is the hardware load on Enode B2? Like whether its processing power is 90% or 80% or whatever. Just like your CPU load. For example, when you are opening too many programs on your computer might sometimes it will just it might fail. Like you don't know. It might fail. It might just crack down or it might get stuck. So when you see the CPU load is very heavy, like it is running at 97, 98% and all that. So the hardware load, S1 TNL load, TNL stands for Transport Network Layer, which on S1 interface, eNodeB is going to have a S1 interface towards S gateway for the user plane traffic. S1 U. Uh, on the S1U interface, what is the load on the S1 wire? Is it fully loaded, or is are you having enough amount of resources available on that wire? So you are totally one node B is requesting the other node B to report three different things. If you take a node B with a hardware plus software present inside in a box. So one node B is coming and talking to the other node B and tell, hey, you please have to tell me about what is your left hand side situation, that is radio resource part, and you have to tell me your middle situation, like whatever the hardware and software you are having, about that hardware and software you tell me, and you have to tell me about your right hand side situation also, that is what is happening on the cable that is connected between you and the router that is connecting you to the S gateway. Is that cable sending the traffic continuously working at 100% load level, or is it working at 50% load level, 40% load level? I would like to know your entire situation, like whatever the problem that you may be facing on any side is a problem. For example, if Node B is allocating too many resources for the mobiles, and if he is not having any kind of resources left out, you try to defer the handover for some time from Node B1 to Node B2, because we know that if you send the user to Node B2, Node B2 will struggle to allocate the resources for our user, because already the resource utilization is high. Or if the hardware load is very heavy on Node B2, even that might cause the problem. So because the mobile equipment may not be able to get a resource from the Enode B or from RRC connection establishment from the Enode B, as its hardware is working overtime and heavily loaded. Or if both these things are perfectly working, like at only 40%, 50% at low levels, but even at that low level, there is lot of traffic arriving from the different mobile phones, lot of mobile phones. So you are using a powerful hardware and you are having like 20 megahertz bandwidth. So you are receiving lot of data from lot of mobiles. The cable that you have connected is only like 10 Mbps cable that is connected to your Enode B. Now all the mobiles together are sending more than 10 Mbps, like 12 Mbps and all that. Your radio resources are not a problem, because we are using a sophisticated hardware and software. That is not a problem. But the amount of total data we are accumulating on the radio interface and processing it is 12 Mbps, but the cable that is available to dispatch the traffic from Enode B to S gateway is only working at a 10 Mbps speed. So now obviously at Enode B 2 MB of data will be struck. So we say that now we are overworking this S1 interface. So even that will cause the problem. So if Enode tells that, hey man, I can accommodate radio resources, my hardware is also fine, but I am facing little problem with the S1 interface. Even in such kind of scenarios, Enode one will think that if I move my mobile phone also, Enode can accommodate the resources and get the data transferred from the mobile to Enode, but Enode hardware also can deal with it and process it, but Enode will not be able to immediately transfer the data into S gateway, as the the cable, the RF Ethernet cable connected between your Enode B towards the routers connecting you to your S gateway, though that cable capacity is very low. Like how this X2 link will be created between two Enode Bs. X2 link, please understand, in LTE, all Enode Bs, all components will communicate with each other by using IP transport mechanism. So one Enode B would be connected to routers, other Enode B would be connected to routers. If two Enode Bs need to exchange the protocol messages, they will be exchanging the protocol messages packed into IP packets. Source IP address will be Enode V1, destination IP address will be Enode V2, and you will be sending the IP packets. So it is just like how the IP packets will move from one computer to another computer. It is just as simple as that. There is uh, no complexity involved there other than that. It is just as simple as it. For example, you can question yourself, how can my computer send IP packet to Google server or YouTube server or Facebook server? Because your computer has IP address, it can send IP packet to anywhere in the world. So eNodeBs are also having IP addresses. So they will be able to exchange the information with one another. So that is how they will be exchanging these messages. So if you remember the X2AP protocol stack, the X2AP protocol messages that are generated by one eNodeB would be packed into SCTP. Those SCTP messages will be packed into IP. At IP, we'll be having the source IP address as eNodeB1 and the destination IP address as eNodeB2. And we send these IP packets with the help of the routers from one row. With the help of the routers, you will be connecting to the other eNodeB. You will send it from one eNodeB to another eNodeB. Once the receiving eNodeB receives these IP packets, it will extract SCTP from that. Inside SCTP, you will have the X2AP messages present inside. That is how this is going to work out.
So, sir, in the radio link, there is no X2 link available.
Sorry?
Like the two eNodeBs in the radio interface, there is no X2 link. Like they will be connecting through routers only.
That part I have already talked about it, right? We have already discussed about it in our basic sessions.
No, like my question is like two eNodeB, like from like X2 link is not on air interface. They will be
They
directly
can,
through the
it can
router
be
only.
on, it can be on air interface. It can be on air interface. I've already talked about it, but I'll again talk about it. The X2AP protocol can actually be packed into SCTP. SCTP packets can be packed into IP. IP is mandatory, but how IP travels is different. For example, IP can travel by using Ethernet and physical cable. We can do that. That is one way of working. Our IP packet can be packed into your microwave frames, and you will be able to transmit it on microwave signals. Okay, so you can do this also. So how IP packets will travel from one eNodeB to another eNodeB, you can determine that depending on like where the eNodeBs are installed. You can determine that. I have already talked about this at the time of introducing the protocol stacks. L2, L1 can be anything. L2, L1 can be Ethernet physical, or it can be microwave frames and microwave signals. If it is the
Okay.
microwave, it is the radio link. It cannot be called as radio link means it is not going to work on NAS protocol, RRC protocol, and all that nonsense. One eNodeB definitely have to make the IP packets. The source IP address is eNodeB1, destination IP address is eNodeB2. This much you cannot change. This is mandatory. Up to here, it is mandatory. Okay, making IP packets is mandate, but how do you send these IP packets is optional. You can send it either by using Ethernet to physical or microwave physical, or you can use ATM and STM cable you can use, and you can actually use the frame relay and even cable. You can do whatever you want. Your data link L2, L1 can be anything. So L2, L1 can be radio based also. For example, if you are installing a eNodeB in a village, you don't want to lay down the costly Ethernet cables or your optical fiber cables, then you can use microwave. Typically, operators will be working on microwave in that scenarios. So it can be there. But these three layers are mandatory. Okay. So one eNodeB is requesting the resource related information from the other eNodeB. The other eNodeB is accepting it first, and then later it is sending the reports one by one in the form of resource status updates. So let us look into these things. Resource status request. So in this, it is going to quote um, like what kind of characteristics it want the other eNodeB to report. Uh, PRB related information, TNL load information, and hardware load information. Okay, so it is going to request for Either all the three or only one or two things you can request or all the three things you can request. So you're asking this report must be sent for which cells and what is the reporting periodicity. How often you want the other node to report you these every 1000 milliseconds, that is 1 second, 2 seconds, 5 seconds, 10 seconds. So if you ask it every 10 seconds, you are requesting the other node B, you need to keep reporting your status every 10 seconds once. I needed to know. So the other node B, which comes back either accepting or rejecting. If it is accepting, it will simply send a positive response. If it is rejecting, it will quote a reason for that, and it can send a failure to you. But if it is accepted, uh, so the whatever the time that you have agreed upon, by following the time, the other node will need to keep reporting these measurements for every cell. So what is the cell ID in that particular cell? How much is the hardware load indication going on? And what is the S1 TNL load from that cell traffic? And what is the radio resource status, like your PRB allocation every 10 milliseconds, average PRB allocation? Like, are you allocating the PRB set to 80% or 75% or 90%, whatever it is, you will be reporting that. So for every cell. So if it is requested for multiple cells, you have to report it for multiple cells, depending on how many neighboring cells you have. If you have multiple neighboring cells, you have to report it for all your neighboring cells. For every cell, you will be reporting these kind of statistics. Okay. Um, So other than this, there is a global communication mechanism called as load information also. One node B can actually send something called as a load information to other node B without even requesting, without even getting a request from the other side. It is like proactive load information sending. So node B one felt that I need to report my load related problem to the node B to myself. So I'm reporting it. So it is not something that is requested by the node B2. You yourself taking the initiative to report it. Like what kind of a thing will be reported as part of this load information? Typically, what will be reported is your interference related problems, especially the uplink interference problems. So when if a node be in a particular cell, if he is having too much interference in this particular cell, uplink interference, you will just ask the help from the neighboring node Bs and neighboring cells. Hey, can you please do the power control on your mobile phones and ask them to reduce their power utilization a little bit so that my interference will come down a little. I would really appreciate that because your mobile phones are really shouting right now. Whatever the signals they are sending, it is causing me too much interference. That is why I'm asking you for your help. So you are reporting like in which cell ID of yours you are facing this uplink interference, and in which cell of the neighboring node B you want the uplink interference to be controlled by reducing the power values utilized by the mobiles. Because in uplink, power control is completely in the hands of eNode B. eNode B would be controlling the power of different mobile phones for uplink operations. So one node B is begging with the other node B that, hey, control your mobile phone's power, man, and help me out to reduce the interference I'm facing in my cell. Why I'm facing in load in my cell and how can you help out? Because your users are almost in the boundary of my cell and they belong to you, but because they're shouting with very high noise, so I'm facing the issue. I'm having high interference. I wanted to reduce it. Help me out here, please. So you are just sending this load information. So it is a proactive measure that you are taking to beg your adjacent node B to help you out to reduce the um, interference situation for yourselves. Okay. Um, all the messages we have studied so far are called as global messages. Why they are called as global? Because they are not at all related to any mobile equipment. point of view. They are not from any mobile's perspective. There is none of the messages we have studied so far are related to any particular mobile phone. They are generic messages that are getting exchanged, like creating a X2 relationship by creating the setup, X2 setup. Now, before we send the X2 setup message, already the X2 interface link will be already created. That X2 link can be created with the help of the routers in the middle between the eNode Bs, or with the help of microwave antenna signal creation between the eNode Bs. It doesn't matter. But the eNode B is the first message they will exchange is X2AP protocol message called as X2 setup request, and the other eNode B is going to accept it to become a friend with this eNode B. So they will keep continuing to modify the keep updating about their configurations. And if any component goes down and comes up, also it will be reported. And as well as eNode Bs are exchanging their their situation every time, like load related informations, so that they can handle with the handovers in a better way. So all these are global information exchange that is getting that is getting on between two eNode Bs. The global information, not related to any particular mobile. But now we are going into the other part, starting with something called as error indication. The speciality of this error indication procedure is this procedure can be a global message. It is related to a global procedure, or it can be related to a UE specific message. First of all, what is this error indication? Um, if you have, if eNode B2, if it has sent any message to eNode B1, um, eNode B1 sees some errors inside that message, but the kind of message we have received is a class 2 message, uh, because class 2 messages don't have the responses. So obviously, eNode B1 will feel helpless because he cannot send any response as it is a class 2 message. So what does eNode B1 can do is it can report this error indication, reporting to eNode B2 that, hey man, you have sent a class 2 protocol message. I know that class 2 protocol message doesn't have any reply because class 2 means no replies. But I have seen something problematic with the class 2 message that you have sent me. So that is why I'm reporting this error indication message to you. So error indication is to explain the other eNode B that the so and so message that you have sent me is wrong. I have found out some mistakes inside that message that you have sent me. Or it could be for class 1 also. How it could be for class 1? For example, if eNode B1, eNode B1 have sent a class 1 request message. Like for example, it is sent a request message to eNode B2. eNode B2 sent a reply back. So there is a response received back. So there is nothing wrong with the request, and the eNode B2 positively responded with a response message. But this response is containing errors. There is no response for response. Response is the last message in the procedure, but the response is containing the errors. So eNode B1 thinks that, okay, eNode B2, when I have sent a proper request, it has generated a response, accepted my request and replying back, but the bugger, he has sent me a wrong response. Inside the response, whatever the IEs it has included, containing some errors. Now I cannot report back with the proper procedure because response doesn't contain another response. So what do I have to do? I will be reporting it with this message called as error indication. So basically, error indication is a procedure that is used to report errors for any messages for which no response is available. You will be sending error indication for that. So if you see any error in any incoming message, provided they cannot be reported by an appropriate failure because those messages won't contain the failure response, that times you will be sending error indication. But error indication is applicable for both UE associated signaling as well as non-UE associated signaling. Meaning is, we are going to study what are those UE associated signaling later, but it is going to be applicable for either one of the types, this error indication procedure. Okay. Um, What details will be there in this error indication? The most important information is message type will be pinpointing that is error and cause, why this error has been caused. And if the error is been caused due to an information element, you will include the critically diagnostics and explain about that information element. You will explain it. Now, if the if the error indication you are sending is for global messages, then these X2AP UEIDs won't be present if it is global messages. Like the messages that we have discussed so far, those messages won't contain X2AP UEIDs because those are global messages. But if you are sending this error indication for any UE specific messages, for example, for UE specific messages are containing errors and you are reporting it, that time you will have to add the X2AP UE IDs. There is something called as old enode BUE X2AP ID, new enode BUE X2AP ID. So you need to include those IDs with which the enode Bs are recognizing the mobile phone. What these IDs are and how they will work out. I will explain you starting from the next procedure onwards. So, but if these are UE specific messages containing errors, to recognize for which mobile message is erroneous, that UE specific ID will be used. Otherwise, those things are optional. Basically, here presents or represent optional. Okay, so but whenever you get a error indication, normally what will be present is cause of the error. And if the error is due to an information element, you will explain about that information element related details with the help of this critically diagnostic package, including the IE related information. Okay. So this particular error indication procedure can be classified to be called as both. It can be coming under global part or UE specific part. Can be classified as both. Okay, now we are starting the mobility procedures are nothing but called as UE specific procedures. So the enode B to enode B both are communicating with each other to establish the handover from one enode B to another enode B. Handover related procedures. Mobility means handover. Okay, how is this? First one, handover preparation procedure. How it works out. So source node B is proposing a handover to target node B called as handover request, and target node B is positively acknowledging back, accepting the handover. Or it could be in a negative way. It can come back and report that sorry man, I don't have resources to allocate your user who would like to come into my cell at this stage right now. Myself facing the problem to allocate the resources to my users only. I will not be in a position to allocate the resources to your users who would like to come into my cell. So I'm rejecting the handover preparation request that you have sent me. Sorry. Normally, when a source node B triggers the handover, before this handover request is triggered by the source node B, your source node B might have already received a message from your mobile phone called as measurement report. In the measurement report, mobile is explaining to source node B, hey, my present cell is not looking good for me. That belongs to you, but now I'm finding the target node B cell to be really, really good. If you can arrange me a handover to go into the target node B cell, I would be ever grateful for you. Can you please do it for me? So mobile begs it with source node B by sending a measurement report like A3 or A5 or something like that. So the critical measurement reports it will send. So source node bit makes a immediate handover decision, and it is now going and talking to target node B to accept the handover of one of his users by sending this handover request message. If target node B accepts it, it comes back with a positive acknowledgement. If target node B decided to reject it, it comes back with a failure message. So what details will be present in these messages in positive acknowledgement case, in negative acknowledgement case? So in case of a request, first of all, what will be present? Request. Handover request message type is representing this handover request. Old node be UEX2 API. So your old node be nothing but your source node be is allocating ID for the mobile. Hey, because I am triggering multiple handovers, for one handover that I'm triggering. For example, there is a traffic signal turned red. Uh, at the traffic signal, there are maybe 100 mobile phones stopped, 100 vehicles stopped, 100 mobile phones stopped. All the 100 mobile phones are in connected state. Let us take one side of the signal, one side of the traffic signal is one cell, the other side of the signal is other cell. Now, all these 100 mobile phones who are in connected state will have to go for a handover. Now, how many handovers the source node B proposes? 100 different handovers. Let us suppose if target node B is accepting only 97 handovers, three handovers are being rejected. How do you segregate which handovers are accepted, which handovers are rejected? You can recognize that with the help of these temporary IDs you create for the X2 operation. So for every handover that is triggered by the source node B, it will allocate one ID to it, so that if the response comes back from the other side, you can find out the response is positive for this guy or not. You can relate to it with the help of this ID. So even if 97 handovers are accepted, three handovers are rejected, you can easily understand which 97 mobile phones handover is accepted, which three mobile phones handover is been rejected. So you can recognize that with the help of this ID. So that is why for every handover that is getting proposed from the source node B, one temporary ID will be attached there. Old node B UEX2AP ID. And the cause of the handover, why source node B is triggering the handover, and to which cell mobile would like to go to. There will be multiple neighboring cells between source cell and target node B, source node B and target node B. There are multiple neighboring cells. To which neighboring cell the mobile is willing to go into. So you are sending that. And this mobile, because he is already in connected state, he would have already been in registered state with a MME, with which MME the mobile is registered. So the MME related information. Why we have to send this MME related information is after the handover is completed, once the mobile arrives into target node B must talk to MME and explain him the situation about the handover that occurred, and explain him that, hey man, one of the mobile who was with a old node B, now he has come into my cell. From now onwards, he will be with me. I'll be dealing with that user. If you want to send any NAS message to the mobile, don't send it to old node B. Send it to me, because I can send it to the mobile. Old node B cannot send it to the mobile, because mobile is not there in the old node B. Is already moved into my cell. So to report this situation to MME, target node we need to know the mobile is registered with which MME. So that is why this information is being quoted: a global unique mobility management entity identity, MME ID. And right now, what is the context the mobile equipment is having in the source cell, present cell? What context he is having? The source node B is explaining all the details. This mobile has been registered with the MME with this S1AP UEID. If you code this ID to MME, MME can recognize this mobile. Source node B is telling it to target. These are the UE security capabilities. These are the PDCP security information that I am maintaining, like star K node B, etc. You will be sending that. What is the UE segregate maximum bitrate that is operating? How many RABs the mobile equipment is having? Radio access bearers, nothing but radio bearer plus S1 bearer, indirectly part of your EPS bearers. If you are having 5 EPS bearers active, there will be 5 ERABs, 5 radio bearers plus 5 S1 bearers. You will be explaining about those ERAB IDs. Each ERAB is getting created, got created with what quality of service, and etc. And um, so um, source node we will tell whether if he is having any downlink pending traffic on his side, which is not yet sent to the mobile equipment. So if it is having the downlink traffic pending, it will ask for a downlink forwarding tunnel uh, from the target node B. Tell the target node B that I have some pending data. If you could create a tunnel ID and give it to me, What is the tunnel ID? I will explain it in the GTPU protocol. But if you can create the tunnel ID and give it to me, I'm really grateful. I will send all the pending traffic for this mobile to you. Similarly, I want a uplink tunnel endpoint also. Sorry, I will be telling you if you want to send any uplink traffic to S gateway, this is the S gateway's IP address and tunnel ID. So once the mobile arrives into your cell, you mobile will be sending the traffic to you. You need to send the traffic to S gateway. This is the S gateway's IP address and this is the S gateway's GTPU tunnel ID. So you have to use these details and send the traffic to S gateway. I won't be sending the traffic to S gateway after the handover is complete. You will be. That is why I'm sending you all this information. And what is the mobile's present RRC context? Like all RRC configuration that the mobile is having, like how many PDCPs are there, how many RLCs are there, how many logical channel IDs are operating, what are the logical channel priorities, MAC configuration, etc., etc. The full RRC context that is ongoing for the mobile in the present cell, everything is packed by the source node B and giving full information to the target. Okay, including some additional trace information and UE history information, like mobile is arriving from which cells. Like if the mobile is under trace, everything it does, like every data piece that he sends or receives, it will be captured or it will be like basically recorded for the government purposes. If the trace is activated, that trace activation is set to true or false. If trace is activated, old would be till now whatever that trace information it has gathered, it will be sending the trace details to the target node B. So by providing everything that the source node B knew, it is proposing a handover to the target. This is the kind of service that I am providing to the mobile with these many ERAPs and with this RRC configuration and everything. So if you decide to accept the handover or not is your choice. Plus, please come back to me and tell me what do you want to do. I would like to know about that. If target node be decided to accept it, so it sends this handover request acknowledgement, a positive acknowledgement it will send back. And at the time of sending this acknowledgement, target node B will create one UE ID for his own reference. So source node B is creating one ID for his reference. Target node B is creating an ID for his own reference. For example, source node B might have requested 50 handovers, but the target node B might not be creating only 50 IDs. Target node B might have created like 400 IDs. Why? Because from one node B there are 50 handovers requested. There are 8 adjacent node Bs or cells available. From every cell there are 50 handovers are getting triggered. Totally there are 400 handovers are triggered. So your target node B wanted to maintain his own IDs, like totally how many handovers are triggered. I wanted to maintain one ID for one handover, irrespective of that handover is triggered by any node B. I will be maintaining my own numbering. So like that, every node B will be maintaining his own numbering for the handover procedure that is taking place. And the next list is for this particular user whose handover has been requested with this ID, target node B is telling that these are the ERABs that I'm admitting, accepting. You have told me that the mobile is totally having 5 ERABs, but I am not accepting 5 ERABs. I am not admitting 2 ERABs. I am admitting only 3 ERABs. 2 ERABs I am rejecting because I don't have enough resources available. I am accepting the handover, but I am not accepting the full-fledged handover. I am accepting some kind of an I don't know, like a shortened version of handover, or like what I would say, like you know, uh, what is the perfect word to use? I'm not getting the perfect word. Downgraded. So downgraded handover. Basically, it is like um, The target guy is telling that I'm not accepting your handover as it is, because you are having enough resources. You are maintaining 5 ERAPs for the mobile happily. But in my cell, the situation is not that. Because you are requesting for the handover as the mobile equipment is about to lose a radio link, I'm agreeing to that. I'm ready to accept it. Very well done. I'm accepting it. But not with everything that you have proposed. And for every ERAP that I'm accepting, I'm going to send you the uplink GTP tunnel endpoint and downlink GTP tunnel endpoint. If you have any uplink pending traffic received out of order traffic, you send it to me, that traffic. If you have any downlink traffic which is not yet dispatched to the mobile, which is received from the S gateway, you give it to me as well. So like that, it will give the tunnel end details, target node B. So source node B will use these tunnel endpoint numbers to send the pending traffic on his box to the target node B. Because once the mobile goes into the target node B cell, it will be dealing with the target node B. Yeah. The traffic must be dealt by the target node B, not by the source node B. So source node B is going to dispatch everything that he has got for particular ERAB on these tunnels. So one ERAB, there will be a set of tunnels that need to be created. Of course, these tunnel IDs, tunnel endpoints are optional. Why they are optional? These tunnel endpoints won't be created for ERABs, which are working for RLC UM mode. They won't be created. They will be created only for RLC AM mode entities. RLC AM mode radio bearers. You will be creating these tunnel endpoints. Your pending traffic forwarding is applicable only for RLC AM mode entities, not for the UM mode entities. So how many ERAPs are admitted, how many ERAPs are not admitted? Of course, if eNode B is having enough resources, the target eNode B, it might accept all the ERAPs. It might not even send this ERAP not admitted list. It is optional. It is saying that I'm accepting the handover with all the ERAPs that you have proposed. Everything is okay for me because I'm having enough resources. Why to reject some ERAPs creation? I can continue the same service the mobile is having as it is. So there is this target node B to source node B transparent container. This is nothing but the configuration that is prepared by the target node B, RRC configuration that is prepared by the target node B, sent to the source node B. Source node B packs this information as part of RRC connection reconfiguration message and send it to the mobile. Hey man, mobile equipment, I'm accepting your handover. So this is the new configuration that you have to use. So targeting would be sending those configuration details to the source, and source is going to pack this information in RRC connection reconfiguration message and send it to the mobile phone, triggering the handover. And if required, the target guy may include the critically diagnostics, but mostly this is optional. So if there is no problem, this won't be present. But um, it could report a handover preparation failure as well. Normally, why failure? It might cause a reason for the failure. It might tell you that I don't have resources or whatever, whatever. For example, I don't have enough resources on my side. For example, no radio resources available in the target cell. It can quote such kind of reasons, and then it can reject it. So that is failure causes. If the handover is accepted for the radio bearers which are operating in AM mode, source node B need to send a status message to the target, explaining to the target about the PDCP sequence numbers that have been successfully transmitted, and from which number onwards the target need to be continued. So this is applicable for the handovers that are accepted. For example, one target node be accepted the handover of a mobile source node be by quoting that old node be X2AP ID and new node be X2AP ID for the accepted handover user. It will be quoting, hey, these ERABs, I am sending the status ERAB ID and our uplink count value, downlink count value up to this particular PDCP sequence number. I have already received the data from the mobile. You need to continue from the next number onwards. Up to this particular sequence number, I have already sent the data to the mobile. You need to continue from the next number onwards. It is like that. You will be reporting these details to the target guy, the uplink count value and downlink count value. And if there are any missing PDUs in the uplink scenario, you will be even reporting that situation to the target guy as well. You will be reporting it that I have in the uplink direction, I have received it up to this particular number, but after that some things are missing and some things are received. So I'm explaining you all that situation which are missing, which are received. It is not continuous. If it is continuous, simply you will be sending uplink count value. If it is not continuous, you have to include this receive status of uplink PDCP SDUs, which SDUs are received, not received, which SDUs are received. You will be reporting it to the other node B, so that once the handover is completed, this same thing will be sent to the mobile equipment, explaining the mobile that, hey man, out of the PDUs that you have sent, out of the SDUs that you have sent, source node B has received so and so SDUs and not received so and so SDUs. He sent me the status report to me. I am reporting it to you, so you need to resume with these missing ones. So target node B will explain this situation to the mobile equipment after the handover is complete. Now, once the handover is successfully completed, target node B recognizes that the mobile equipment has arrived into his cell successfully. So target node B also speaks to MME and report the MME that the handover is completed successfully. Everything is done successfully. After all the steps related to handover are done, your target node B comes and tells the source node B that, hey man, you can forget about this mobile by releasing the whatever the context you are maintaining specific to this mobile phone. You can throw all the information into dustbin and forget about this mobile. Why? The reason is handover is complete. I'm talking about which user's handover is complete. The user with whom the users who we are identifying with these IDs. So I'm talking about this particular user with these IDs. Everything is done successfully, like handover is done successfully. The mobile arrived into my cell and done and dusted. So you can forget about this user. I'm giving you the guarantee that from now onwards, I will be helping you out that mobile. You don't need to worry about this mobile and you can forget about this guy. You can deal with your own users. So target node B is confirming that handover successful scenario to the source node B by quoting these numbers with which you can identify which mobile phone's handover has been successful. And the last message that we have to study here is handover cancel. Now, after any moment in time, handover is triggered. After the handover is triggered for any reason, source node B decide to cancel the handover. Why typically source node B decides to cancel the handover? For example, first mobile sends a measurement report requesting for a handover, and the source node B triggered the handover to target node B by considering that measurement report. After some time, before even the handover is been accepted or rejected by the target node B, mobile equipment sent other measurement report to source node B, told him that, hey man, I am feeling really good in the present cell now. I don't want to do a handover. I want to continue in my present cell itself. He told to source node B. Source node B goes and tells to the target node B, I'm canceling the handover that I have triggered. Don't bother about the handover. My mobile has has took a U-turn, just like a politician. Earlier he wanted a handover, now he is not wanting a handover, so I'm canceling it. It's just like dosa cancel. Okay, so you order a dosa. Just before the guy is decided to put the dosa, one of your friend come and told, "Hey, there is urgent work. Come on, let us go." So now you told that dosa guy that cancel dosa. I'm going. So that is that. So handover cancel. So simply he'll quote which user's handover is cancelled, identified with that enodb ID. So you have triggered 100 handovers. Out of those 100 handovers, that the one enodb triggered, uh, four guys have took a U-turn on the at the signal after that signal turned green. Till that time they were demanding handover, but the moment when the enodb is like when the enodb is um, about to do the handover, you those users took a U-turn and going back and sent a measurement report to source InnoDB that I don't want handover. So that InnoDB is saying that earlier I have triggered 100 handovers. Um, out of those handover, every handover I have given a different number. Out of those numbers, the guy with the number 31, 52, and 73, these three guys handovers are cancelled because these three guys took a U-turn and came back into my cell, and they have told me that they wanted to continue in my cell itself. So I'm cancelling the handover. Don't proceed with that. Now, if the target node B has already created a ID for this mobile at the time of handover, then that ID also will be quoted in this message. But if it is not, then this will be optional. If it is not created the ID for the mobile yet, the target node B at the time of triggering the handover, if the target node B did not create the ID, then this is optional. But if it is created, it will be kept. What is the cause? Typical cause is like mobile has told me to do so. Mobile is telling me that I don't want to move to the target cell. So that is the kind of reason you will be quoting. So all these are handover procedures that we have studied, and that is the end of X2AP protocol. That's it. Is the communication that happens between one enode B to another enode B. Nothing more. So this is the X2AP protocol document. So you have the scope, references, definitions, class 1 procedure with response, class 2 procedure without response, um, different symbols, abbreviations, etc. And what is the meaning of a procedure? Every procedure may contain many messages. Every message may contain many IEs. Every IE contain a value. And X2AP procedures can be classified into other category also. Mobility procedures related to the triggering of the handover and dealing with those handovers. And the global procedures are to establish relationship between two nodebs and maintain that relationship by exchanging their common information related to the cells they are having and the neighboring cells they are having, etc. So what are the functions
Hello,
of?
excuse me, sir.
Yes.
Uh, I have one doubt that in X2 setup procedure, they must create that HTTP connection and share their source and destination IP. Am I right, sir?
Yes.
Uh,
Yes.
so I don't see that details, sir. Even if I missed, can you just show me that details, sir? I'm not. Uh, hmm.
Which details you mean?
That HTTP creation details, source IP, destination IP, what the messages that they
That we'll see in the
exchange.
log
I don't.
files. That we'll see in the log analysis time. We will see it. No, don't worry about it.
Okay, but in that information element, the field is there, or here I don't see that also.
Which one you don't see? You mean?
That basic that details of that source IP, destination IP, that information field should be there, right, sir?
Not in X2 protocol. That will be there. It will be there in every protocol. Um, see, you Did you go through the OSI sessions already, or you did not?
Yeah, yeah, half I completed, sir.
Sorry?
15 videos. Half completed, sir. 15 videos
Okay.
I have completed.
Okay. That is the reason why you have to complete the protocols, all of them. The idea is yes, X2AP protocol messages are prepared by X2AP application software. It will prepare it. After the messages are prepared, those messages are converted into binary information, your digital data ones and zeros, and that message will be sent to the lower layer. Which layer? To SCTP. For this, SCTP adds the header. SCTP header will be added by SCTP protocol. So that is some additional binary information to already received binary coming from the X1AP. Some more additional binary bits will be added. Those binary bits are SCTP header. Once SCTP sends it to the next protocol layer, which is IP, IP will be adding its own header. In the IP header, you will have the source IP address and destination IP address. So in this header, this header is again another binary, additional binary information to the already received binary plus binary. So binary plus binary. So we are going to, we are only studying this top binary part, which is the X2AP part. We are not studying the X2AP headers. We are not studying the IP headers. We are not looking into those aspects. Those things you need to learn in the OSI classes, how the SCTP headers will work and how IP headers will work.
Yeah. Okay, sir. Thank you.
Okay, we are only looking into this X2AP protocol message containing what information elements inside. Inside X2AP, you will not have the IP addresses. Those headers will be added at IP layer. Every protocol layer is responsible for their own tasks. X2AP doesn't do the task of IP protocol. IP protocol is responsible for generating IP packets and sending it with the help of the routers. X2AP is not responsible for that. X2AP is responsible only for X2AP related activities. Which are the X2AP related activities? Dealing with mobility management, leading with load management, exchanging load related information. If there are any errors, exchange information related to those error conditions. Resetting the X2 if any node B goes down and comes up. Setting up the X2 interface communication with one node B to another node B, and node B configuration update in any node B configuration gets changed. These are the only functions the X2AP is responsible for, and the X2AP, in all X2AP messages, only the information that we attach will all be related to these 6 functionalities. That's all. You will never find any information other than these 6 functionalities in the X2AP protocol messages. You will not find SCTP headers and IP headers also in X2AP. You will not find that. Then we don't need the protocol stack. If everything is done by X2AP, why do we need to have the protocol stack with 5 layers, 6 layers, 7 layers, etc.? Not needed. Only one layer will do everything. It is not the way protocol stacks work. Application protocol is responsible only with his jobs. It will give the transport to somebody else. Here, transport is the duty of IP and SCTP guys. Okay. So mobility management is dealing with your handovers. Load management is exchanging load related information between two node base. If there are any errors occur, they will be exchanging error messages, resetting, setting up the X2 interface. If anybody goes down and comes up, it becomes a reset. If any one node base configuration is getting updated, we perform node B configuration update. If we see the same procedures, uh, total functions are 6 functions in X2AP interface. Number of procedures are 11 procedures. So order we have studied is X2 setup first, node B configuration update, reset, and then load indication, resource status reporting initiation, resource status reporting, and any errors occur, error indication. And mobility handover related, we have 4 things: handover preparation, request and acceptance, and exchanging the PDCP sequence numbers that are ongoing in the source node B to target node B. And target node B is explaining about the handover success to source and asking the source to forget about the mobile, which is UE context. And if already handover is triggered and if you want to cancel it, you will be triggering handover cancel. So we have 11 procedures in total for 6 different functionalities. X2AP is performing only just 6 functions. Total procedures are 11. We have 11 procedures. So in every procedure, for example, we have class 1, 5 procedures we have in class 1. So handover request procedure, if you trigger this message, you have a positive acknowledgement, you can have a negative acknowledgement. For reset, you can only have a positive acknowledgement. X2 setup, you can have when you send a request, there can be a positive acknowledgement, there can be a negative acknowledgement. eNodeB configuration update also positive, negative. Resource status reporting also there can be positive, negative. But class 2 procedures are the ones which are single-sided messages, unidirectional. You send the load information. You don't care about what the other guy responds back. Other guy won't respond back. It'll be silently taking the load information which we are sending either in the form of load information or in the form of resource status update. Whatever you send, it will be silently taking it. Handover cancel is also class 2. You never expect any reply from the other guy. You just send cancel and the other guy will cancel it. You don't want to hear anything from the other guy. SN status transfer also is unidirectional. You send just your PDCP status report to the other guy and you expect the other guy to just listen to you and note down all the information you reported him. UE context release. Once the handover is completed, target will tell the source guy that this is the last message I'm sending you related to this mobile phone. You can forget about the mobile because the handover is completed. That is what I'm reporting it to you. Like that. Error indication is also class 2. If there are any errors in any of the messages, any of the response messages or the failure messages, there are containing any errors, or class 2 messages containing any errors, error indication happens. If request messages contain any errors, failures will happen. Failure reply you will get back. So requests are specially dealt. Your request is wrong, containing wrong things, you will get a failure. But if responses are containing wrong information, or your class 2 messages or any of the class 2 messages are containing wrong details, what do you get is error indication from the other side. And mobility procedures, etc. I have explained all these things. Handover preparation, SN status transfer, UE context release, handover cancel we have, and general global procedures, load information, not in the order that I have taught you, but in the different order. Error indication, X2 setup is establishing a relationship between two eNodeBs. Reset, if any eNodeB goes down and comes up abnormal failures. eNodeB configuration update, and yeah, that's all. These are the procedures. And all the messages that I have showed you will be explained in the form of the tables. So these are the tables I have copy pasted into the PPT and sent to you. So when you are proposing for a handover, handover request message is containing the details like what is the UE's context that is going on right now, and proposing the handover. And the other guy, if it is accepting it, it will send the acceptance with how many ERABs admitted, how many ERABs not admitted because of load problems, etc. And what is the configuration that the target node is preparing in this, on his cell, which will be sent to mobile equipment in a message called as RRC connection reconfiguration request. If this is the positive acknowledgement, if this is a negative acknowledgement, you will be getting a failure with the cause. So like that, all the messages that we have studied so far are going to contain these tables. So X2 setup request table, X2 setup response table, like that, all the messages we have are explained here in the form of tables, what information elements that are going to be present inside, which I have already explained you in the PPT. I will send you this document. So you'll have to go through this document, at least highlighted part you can go through it. These are very small documents and small protocol, X2AP protocol, very few messages we have to establish the relationship between two eNodeBs and to discuss to have a discussion between two nodebs about handover. Okay, somebody was speaking. I have interrupted. What was the question?
As point of interview point of view, like we should remember all this table content, sir. Like
Depending on which project you are going to keep. If you are going to keep any project related to enodb testing, for example, you need to remember these things. You need to logically remember it. For example, if you ask me even night 2 o'clock, if you wake me up and ask me, I will be able to tell most of these informations because I know I have created a logic in my head. I've constructed a logic. So based on that, I can understand if one enodb is proposing a handover, what kind of a details I need to send. You need to send how many ERABs the mobile is having right now because you need to tell how many services the mobile is having. You must tell this to target enodb because target enodb need to create a similar kind of a configuration on his side while accepting the handover. So you need to send that information like that. You need to like build a logic in your head why this particular parameter is important while proposing the handover. Uh, you have to think about it in your head. If you don't think in the terms, if you want to bluntly remember just like a ninth standard 10th standard person bugging the subject, you will never be able to remember these things at all. But depending on you don't need to remember all the IEs related to all the protocols. You are going to choose one or two projects on one or two protocols. Whichever protocols that you decided to put it in your resume for project execution, those protocols you must work out on, and you need to remember all the for at least the most important messages in that protocol. You must remember what information elements that are going to be present inside it, because when you are going to explain to your interviewer that I have worked on this X2AP protocol testing for 1 year, 365 days I have worked on this project, and you tell them that I did not remember even a single information that one node be sending to other node be, interview will never believe you. Even if you are not a mugging person, if you work on a project on a X2AP protocol testing for 365 days, 1 year, you will automatically remember everything. You will never ever forget it. Even if I ask you by waking you up at night 12 o'clock, you will be able to tell what details will be present inside that message if you work that long. So definitely when you are going to say that I have worked on one of these telecom protocol testing LTE projects, so you have to you have to back up that claim by substantiating it with material witness, by explaining them about the information elements that are present inside these messages. But not for all the protocols. That is the luckiest part. Depending on the projects that you keep, you have to work out on that.